Hi students, so in this video I'm going to explain to you what do you mean by resolution of a force and why do we do it. So in order to explain this problem I have a small example of a force here of 8 Newton which is inclined at an angle of 40 degrees from the horizontal, and I want to resolve this forces. I want to resolve this force in the vertical and the horizontal component, meaning I want to know how much force I have to apply in the vertical direction and the horizontal direction in order to get a net force of 8 Newton in this direction here. So I'm going to take the help of my friend Joe here for this problem. Right. So I want to know with what force I have to push Joe in the vertical direction and the horizontal direction in order to get a net resultant of 8 Newton. So I'm going to get the help of my friend Harry and Sam here. Place them in the horizontal and vertical direction. And I want to know with how much force should they push Joe in the upward and sideways direction to Joe have experience a force of 8 Newton in this direction. So I'm going to calculate this using my friend the calculator. So make sure that your calculator is in the degree mode before you do any problems, because my system over there is in degrees. So I'm going to first calculate my vertical component, which is F sine of theta. And how do I do that? So my force given here is 8 newtons. So 8 times sine of theta, which is 40 degrees, close bracket. I get a resultant of 5.14. I'm going to only use 2 decimal places because 2 decimal places is more than enough of accuracy. So I'm going to write 5.14 Newton here. That's 5.14 Newton. And in order to determine the horizontal component, the formula used is F cos of theta. So again, my force is 8. F cos of theta is 40 degrees. And I get a resultant of 6.128. So F cos theta is 6.128. What this means is Harry will have to push Joe in the horizontal direction with a force of 6.12, and Sam will have to push Joe in the vertical direction with a force of 5.1 Newton in order for Joe to have experience a force of 8 Newton. Now, this is a system of forces. Now, what does equilibrium mean? Now, what I want to happen here is Harry is pushing Joe in this direction and Sam in the vertical direction. I do not want Joe to move. I want Joe to stay there. So this is the net force that Joe will experience, 8 Newton in that direction there. Now I want to know what force should I apply in what direction for Joe to not move at all. That would mean that this system of forces would be in equilibrium, because right now if I leave the system of forces that way, Joe will fall in that direction. So now I'm going to take the help of my friend Ryan here and ask him to apply a force of 8 Newton in the opposite direction to which Joe is experiencing a force of 8 Newton. What is it? So now Ryan here is applying a force of 8 Newton from this direction, Harry 6.12 from this direction, Sam 5.1 in this direction. What is going to happen is this system of forces is now in equilibrium. That means Joe is not going to move anywhere. He's going to be stationary there. And the force that Ryan is applying of 8 Newton in this direction is called the equilibrant force, or it is that force that needs to be applied to a system for the system of forces to be stationary. That is, I need them forces to be like that. Now I'm going to show you this system in in plain view. So this is what it is going to look like. That's Joe standing there. That's Sam pushing him in the vertical direction. That's Harry pushing him in the horizontal direction, and Ryan applying a force of 8 Newton in this direction, so that Joe there stands stationary. And this